Did you know that there are some bacteria out there that can cause cancer? And now I don't mean this to be like an all case, like all bacteria can cause it, but I just want to highlight a specific example, and I'll also address an article that talks about this really well. But basically, there is a bacteria called Helicobacter pylori, or just simply known as H. pylori. It is present in the gastrolumen, so like this, or this like the stomach lumen or gastrolumen. The lumen is basically, if this is like the stomach, there's like mucous membranes. The lumen is basically like the middle. So it's basically where all the acid is in the stomach. I drew a picture here to show that. Just like the stomach, this is hydrochloric acid. That pink thing is supposed to be the H. pylori. Uh, thing. Also, one more thing I wanted to mention: how H. pylori survives. It basically can release something called urease, which when reacting with the acid, it produces ammonia. That ammonia kind of creates a basic environment for the H. pylori, so it can survive. Now, this silly cartoon image is from an anime called Cells at Work. I'm gonna be doing a reaction video on that anime soon. I feel like it's a really, really good anime to help understand how the body works. They go into all sorts of things like red blood cells, white blood cells, immunity. It's really cool. You guys should give that a watch if you haven't. But I'm just gonna go through H. pylori. I know you see all this text. I don't want to confuse you. So, H. pylori does affect 50% of the world's population. It's really dangerous if left untreated without with like you don't without antibiotics or whatever. It does cause ulcers. Ulcers is basically where the stomach has a mucus lining. So like this, it's the white thing would be the mucus. H. pylori can, the things that it releases, like it's like components can destroy the mucus, and that results in the acid kind of eating up like the actual stomach lining. So like if I remove that, you see how there's like excess, there's like direct contact between the acid and the stomach lining. So that's a side effect of H. pylori. Some causes of H. pylori from the article that they mentioned is vitamin deficiency, specifically B12. You can have also iron deficient cases. This isn't like if you have iron deficiency, you're gonna get H. pylori. Don't worry about that. So this is they talked about iron deficiency anemia. So anemia is basically just low oxygen delivery. That's just a general term. Now, the thing that actually struck me is that H. pylori is more common in individuals with individuals and groups in low socioeconomic standings, and that a reason for that is also because the food they eat tend to be unsanitary, and H. pylori tend to exist in that type of food. Probably more like fatty food, meaty food, foods that can easily get unsanitary. Yeah. So H. pylori does a lot of nasty things. I'm gonna go into like the molecular kind of reason why and how it actually works. So to start, H. pylori does have these surface proteins. They're called FLA, F flat A and flat B. We're just gonna call it that. Um, Usually, you would have white blood cells, also known as leukocytes. They would recognize these surface proteins, and like the way they recognize it, they have something called toll like receptors. Basically, without getting into too much detail, that this is toll like receptors, or TLRs, are like a type of protein that, for example, um if you have like a castle, which would be like the cell. This is like the castle gates. This is the cell. This is the castle gates, and you have these like toxic, evil things in the outside. So sometimes these guys might come inside the castle gates. Oh, oh no. Sometimes these guys might come into the castle gates, and toll-like receptors can like bind to somewhere on these pathogens. So these bad guys represent pathogens. and the TLR can say, "Oh, you're a bad guy." So then the white blood cells or nucleocytes come and destroy it through a process called phagocytosis. So basically, in a normal case with flat A and flat B, you would have toll-like receptors to detect that H. pylori is bad. But the tricky thing is, there's a specific toll-like receptor that does recognize it, which is according to the article, TLR5. But the reason why H. pylori can actually exist, and it's actually in 50% of the world's population, is that TLR5 does not work on flat A. It's like if this is H. pylori, and I try to put uh, my TLR5 here, it just doesn't stick, kind of, and I can't recognize it. So then, or the body can't recognize it. So then it just enters in, and it can proliferate and basically grow rapidly. That's one mechanism how H. pylori is able to like succeed. Really, another one, it actually releases two very not toxic, but very bad things. I'm just gonna call them bad generally. So one of them being CAG A, and one of them being VAC A. So basically, CAG A. This looks like an S. It's a G. Basically, CAG A. It helps with okay. It doesn't. It helps H. pylori kind of attack the host cells. And CAG A is a type of oncoprotein. So you might have heard an oncogene before. Oncogene is a gene that can cause that has the ability to become. Wait, if a cell has a gene that's an oncogene, it has the ability to become cancerous if it's mutated. That's what an oncogene is. An oncoprotein is the exact same thing, except that when there's a protein in the cell, it can induce cancer-like growth in the cell. So CAG-A is an oncoprotein. I'm just gonna write oncoprotein. So it's an oncoprotein. Now VAC-A, it destroys cells. So one thing it does that I read in the article is that it it attaches to the mitochondria of these cells. So this is the mitochondria. It's like it goes into the mitochondria of cells, and it basically causes a membrane potential change in the mitochondria that causes cytochrome C to leave or to like get removed. Cytochrome C is very important in the electron transport chain. It's one of those it moves electrons. I don't remember which part or between which channels, but it's very important there. So if you get rid of it, that causes cell death. So, and they called it an article apoptosis. Aptop oh god. Apoptosis. Ap Apoptosis. My bad. So VAC A does that. VAC A also acts as an immunosuppressor. So what an immunosuppressor is, say for example, if I get infected with H. pylori, my immune system will act up. It will say, "Oh, there's something there. I need to get rid of it." And typically, H. pylori doesn't want to get uh it doesn't want to die, or it wants to like remain alive. So you have like a Red Queen effect where the H. pylori has I don't know if it evolved this. I'm not really sure how it has this mechanism, but basically it can cause our immune cells, like our T cells, basically are like kill like they kind of destroy pathogens. They cause this to be activated less. They regulate it, and that's why it's called immunosuppressing. And VAC C here VAC C A can do that. Now actually I want to get into like a bit of the genetics parts. If you're not interested in this part, you can really skip this. This is more so like so I understand it. Um, But here you have a specific gene area called CAG-PAI. It's like a region in the gene that's involved with this, the CAG part, and we talked about CAG-A, so it's related to this. But basically, this codes for a protein called T4SS, or CAG type 4 secretion system, and this actually allows CAG to get inside the cells. So if we didn't have T4SS, then you can't really have the injection of oncoprotein into the cell. Like I talked about how CAG-A was an oncoprotein. So if you don't have this, if you don't have all this, then you can't inject anything into the cell. So the cell would be safe. Um, but yeah, in general, cancer can be uh, created because of this like system of T4SS and CAG-A. Uh, the article, yeah, so they call it a type 1 carcinogen, and it can cause cancer. So I think that's the main point. Yeah, I do feel like that was a bit dense, but I hope that treatments, wash your hands, be clean, make sure you're not reusing dishes. Um, don't put your hand in your mouth after like touching the ground or touching something else, cause it doesn't only exist in food. It can exist anywhere. Like anywhere where there's food or feces. So just be careful. And yeah, I think that's it. Thank you for watching. Have a great day, guys. See ya.